Today we're taking a look at sections 8-1 and 8-2, and we'll be talking about hypothesis testing. First of all, in 8-1 we have an overview. It says, in statistics, a hypothesis is a statement or claim about a property of a population. A hypothesis test is a standard procedure for testing a claim about a property of a population. And what's very important as we look at Chapter 8 and hypothesis testing is the rare event rule for inferential statistics. And it says, if under a given assumption the probability of a particular observed event is exceptionally small, we conclude that the assumption is probably not correct. Okay, so let's move on to 8-2 on the basics of hypothesis testing. In 8-2 we break the process of hypothesis testing down into its components. And then in later sections 8-3 and from there on out, we put the components together. So right now we're looking at each part independently and then put everything together in the next section. Okay, so the first thing we have to have is what we call the null hypothesis, and that is denoted by the symbol H sub 0. H sub 0. That means the null hypothesis. And what these look like is that a statement that a population parameter, and we're only going to limit ourselves to talk about means and proportions, is equal to some value. And so what identifies it as a null hypothesis is the state of equality. So every null hypothesis will have an equal sign in it. Okay, and the alternative hypothesis is denoted by the symbol H sub 1. And for it, we're going to see an inequality symbol, less than, greater than, or not equal to. So the statement that the population parameter is less than, greater than, not equal to some value would result in the alternative hypothesis. Now, when you are forming your own claims, if you are conducting a study and you want to use a hypothesis test to support your claim, you want the claim to be worded so that it becomes the alternative hypothesis. And so we'll talk more about that as we look at the entire process and we talk about how you can use this in your project. Okay, so far we have two components: the null hypothesis, which contains the statement of equality pertaining to a population parameter; the alternative hypothesis, which is a statement about a population parameter that has less than, greater than, or not equal to. Okay, our third component is what we call the test statistic. And we have different lines for different parameters or proportions, which is actually what we'll do in section 8-3. The test statistic is calculated, in this case it's a z value, p hat minus p times the square root of n, which is the sample size, divided by the square root of p times q. Okay, and for a mean, it depends on whether we know the value of the population standard deviation or we don't. If we do, it's a z-score. If we don't, it is a t-score, student t-distribution, which we looked at when we started estimating in the last section. So, we're not going to do standard deviation and variance, so anything, the sections relating to that we'll skip, and likewise any material that you find in the sections relating to the standard deviation or the variance. Okay, critical region is a set of all values of the test statistic that cause rejection of the null hypothesis. And this critical region is determined by the significance level, and the significance level is denoted by alpha, and that is the probability that the test statistic will fall in the critical region when the null hypothesis is true, causing you to reject a true null hypothesis. The critical value is the value that separates the critical region, where the null hypothesis is rejected, from the values of the test statistic that do not lead to rejection of the null hypothesis. Okay, so when we talk about hypothesis testing, we have different types of tests. We can have a two-tailed test, a left-tailed test, and a right-tailed test. So if you have confidence intervals on a card, you may want to put on the other side hypothesis testing critical values for proportions. For a two-tailed test, if alpha equals 0.05, we have noticed two critical values. When we have a left-tailed test, our critical values are negative. When we have a right-tailed test, our critical values are positive. And the way you determine which type of test you have, it's a two-tailed test when the alternative hypothesis includes not equal to. So two-tailed, it goes with not equal to. Left-tailed, it goes with less than. And right-tailed test goes with greater than in the alternative hypothesis. So that determines what kind of test you have, two-tailed, left-tailed, or right-tailed. All right, when I say the traditional method, the book has changed this to a new name. They're calling it the critical value method. So if you see, I think I corrected it one place in the notes and I forgot to correct it here, but traditional method means the critical value method. And we're going to do that one first, and then we'll talk about the p-value method when we move to the calculator. All right, decision making in the traditional method. We reject the null hypothesis if our test statistic, and remember that is the value that we calculate using one of these formulas, if that value falls in the critical region. So we reject the null hypothesis if the test statistic falls in the critical region. We fail to reject, notice it doesn't say we accept, we fail to reject the null hypothesis if the test statistic does not fall in the critical region. Alright, I'm assuming that the page number on this has changed. Yes, it's 389. So let me make a correction there. Use a flow chart for the wording of the final conclusion. And when we start doing different tests, I will show you that, and we'll talk about it actually in just a moment. So again, critical value methods, we want to figure out the null hypothesis and the alternative hypothesis in symbolic form. We indicate which one represents the claim. This is something the book doesn't emphasize, but I find that that is helpful when you get to the final step and you're trying to word your conclusion. So I always identify the claim. Determine whether the test is right-tailed, left-tailed, or two-tailed, and determine the significance level alpha. We draw the curve to match the information we have above, indicate the critical region. We compute the test statistic and we place it on the drawing of the normal curve. If it falls in the critical region, then we reject the null hypothesis. If it doesn't fall in the critical region, we fail to reject. And then finally, we use the flowchart to word the conclusion. So let's move to the book. I want to point out some things in the book. And I may have to adjust my windows slightly. Alright, this is on page 385. Alright, this is what they outline as the critical value or the traditional method. They have 8 steps. I don't remember how many steps I had. But it's very similar to what I have. I also like I said, identify claim, identified the specific claim. Okay, so they did put it in here. They didn't used to, so they moved in and done that. So that's a flow chart you can use. The other thing I wanted to show you was the flow chart for the wording. I think I need to go another page or two. Yeah, it's on 89. Alright, let me move my window over again. This is on page 389, and it's the flow chart. What type of test, and you identify left-tailed, right-tailed, or two-tailed. Is the test statistic to the right or left of center? And it tells you how to calculate the p-value. Okay. Also, they give you a procedure for finding p-values. So that's for finding the p-value. That's not actually what I want. I want the wording chart. And it looks very much like that. And maybe they don't have it. Don't tell me if they got rid of it. They may have gotten rid of it. I actually do not see it. But it was a chart similar to that. Okay. Looks like they got rid of it, so I'll have to add some additional help with that when we get into the next section and we're actually doing a hypothesis test. I'll give you some additional help on that. Okay, so at this point, I guess what we're ready to do is some practice. In the exercises, what they're doing is they are having us do different parts of the hypothesis test in isolation, so you're not actually completing the whole thing. We'll start completing the whole hypothesis test in section 8-3.